Everyone, welcome to the video of heat transfer. In this particular video, we'll discuss about the objective and the course outcome. Objective of this course, that is the heat transfer, is to build a solid foundation in heat transfer, exposing the students to the three basic modes of heat transfer, that is conduction, convection and radiation. That means essentially what we'll see in this course is that there are three modes of heat transfer, that is how heat transfer, that is conduction, that means heat can be transferred by conduction, convection and radiation. Conduction will basically see in solid objects, convection will see normally in fluids, and radiation, it does not require any material medium. That will go into the details in our next lectures. Next is to obtain knowledge of the governing equation and solution procedure for the three modes, along with the solution of practical problems using empirical correlations. So there are few governing equations or governing laws which governs how heat transfer will happen by conduction or how heat transfer will happen by convection or radiation. So we'll have to obtain knowledge about that to solve the practical problems using empirical correlations for different modes of heat transfer. Then to understand boiling and condensation heat transfer and the analysis and design of heat exchangers. So there is another concept of boiling and condensation that we'll also look in this course, and we'll also see how a heat exchanger works and how to design and do the analysis of a heat exchanger. Course content. So these are the 5 modules that you have to learn in this course, that is introduction and convective heat transfer, then introduction and conductive heat transfer, then convective heat transfer, then third is radiation heat transfer, then heat exchanger, and the last one is boiling and condensation and mass transfer. So in the introduction and conductive heat transfer, we'll basically see the governing laws and the modes of heat transfer, and we'll see few correlation of conductive heat transfer, how conductive heat transfer occurs. We'll go into the details of that. Then in the next module, we'll go into the details of convective heat transfer, and the third module we'll see the radiation heat transfer in details, and in the fourth we'll see the design and analysis of heat exchanger, and in the fifth we'll see the boiling, condensation and mass transfer. Okay, so what will be the course outcome? That means what we'll be able to do as a engineer after doing this course. So you will be able to formulate and analyze a heat transfer problem involving any of the three modes of heat transfer. Then you will also be able to obtain exact solution for the temperature variation using analytical method where possible. Then you will be able to employ approximate method or empirical correlation to evaluate the rate of heat transfer. Then you will be also able to design devices such as heat exchanger and estimate the insulation needed to reduce heat losses wherever necessary. So we'll discuss a few typical heat transfer problems so that you have at least a brief idea what the things we'll be discussing in this course. So you can see in the image here there are two pipes. I have written here it is double pipe heat exchanger of counterflow. Two pipes, that is in the inner pipe fluid 1 is flowing in and fluid 1 is also flowing out. In the outer pipe that is bigger diameter, you can see fluid 2 is flowing in and it is flowing out. So let's say the fluid 1 is a colder fluid and fluid 2 is the hotter fluid. Let us take an example. Suppose you are working in a chemical factory where a very hot chemical is to be is because of the process, the hot chemical is coming out as a waste, but you can't dispose the hot chemicals because of the high temperature. Okay, so before disposing of the chemicals, let us say you want to cool it off, or even you can say before going for the chemical reaction you want the chemical to be heated. Okay, in either case we can employ a heat exchanger or counterflow heat exchanger, to be precise, like this. That means in one pipe cold fluid will be flowing, in another pipe hot fluid will be flowing. So let us assume that the fluid 1 is the hot fluid and the fluid 2 is the cold fluid. So as the fluid 1 is flowing in the inner pipe, it will gradually lose the heat that it is containing, and it will the temperature of the fluid will gradually decrease, and the fluid, this loss in heat will be gained by the fluid 2, that is the cold fluid in the outer pipe. The temperature will gradually increase. So as a design engineer, you will be able to, if I have given you certain data that I want my inlet fluid 1 temperature is say 100 degrees Celsius, and I want the outlet fluid 1 temperature to be 25 degrees Celsius. So you will be able to design what should be the length of this pipe, okay, what should be the diameter of this pipe, and all those things you will be able to design, okay, given on this much data. Okay, so let us say, even if I say that this is the length is fixed, then you will be able to calculate and say what will be the outlet temperature. Okay, I think you got an idea. So let us see another typical problem. Suppose there is a furnace inside which I want a metal surface to be come to a certain temperature, let us say 700 degrees Celsius. The outside furnace temperature is 30 degrees Celsius, and inside that furnace temperature is 1000 degrees Celsius. So at what velocity I should roll the roller so that before reaching out, the temperature of this particular metal surface reach 700 degrees Celsius. So I will be able to calculate, after going through this course, I will be able to calculate what should be the velocity also. Okay, the next, suppose this is also one of the very common example of heat exchanger that is also used in electronics. That is, you can see I have shown a figure of motherboard of a computer that you will see in your system. If you have a system in your house, you can open the CPU and you can see the motherboard. Okay, you will see this silver color, these plates are actually the heat sinks that you will see on the top of your processor, or if you install a graphics card, you will see this kind of heat sinks. Okay, so these chips and everything, they have a precise temperature. Okay, if the temperature of those chips, that is a processor and all, if it reaches or if it is increased after a critical value, their performance will tremendously go down. So they have to maintain at a certain temperature, let us say 50 degrees Celsius or 70 degrees Celsius. So as a heat exchanger engineer, as a heat transfer engineer, we'll be able to design how this heat sinks or this extended surface will work, and how much air velocity you have to give so that it is maintained at the temperature of the chips is maintained at 70 degree or 50 degrees Celsius, suppose. Okay, so those are the few typical examples I have shown you that you might be able to solve as a heat transfer engineer, okay, after completion of this course. Thank you.